This is Chapter 2, Teach the Doc. So as you can see here, we start off with our table asking us to complete the following. And we have the particle, the mass, which is the AMU, and the charge. So a proton is 1.00727. That's given to us. It is a +1 charge. A neutron is 1.00866, and it's a 0 because neutron is neutral. And then an electron has almost no mass, and it is 0.00055, and it has a -1 charge. And you can see the answers filled in there for that. And then the next part, we have to look up the atomic numbers for each of the following elements using a periodic table. Carbon is 6, iron is 26, and bromine is 35. I think I even said the names correctly. Fe is definitely iron, and Br is bromine. So yes, I did say them correctly. Okay. The next step is mass number is equal to the numbers of protons and neutrons. And the next part is to complete the table on atomic number and isotopes. And it gives us the information of chlorine that has the mass number of 35, but an atomic number of 17. So we look at our handy dandy periodic table, and we go for 17, and 17 atomic mass number means that we have 17 protons, and we'll put the number 35 under mass number. To get our number of neutrons, we take 35 minus 17, which is 18. There is no charge listed here, so we put 0, and the number of electrons is always going to be equal to the number of protons. So electrons is 17 as well. And as you can see, that's filled out. 17, 18, 17, 35, and 0 for chlorine. And then we have zinc with a 64 for the atomic mass, 30 for the atomic number, and a +2 charge. So the charge will be 2 plus, the mass number is 64, and the protons is 30. To get our neutrons, we'll take 64 minus 30, which is 34. To get our protons, we just do the opposite of what the charge is. So 30 minus 2 is 28. So it's 30 protons, 34 neutrons, 28 electrons, 64 mass number, and +2 charge. The next step, all we're given to work with is that we have 34 neutrons, a mass number of 65, and a charge of +3. And we have to find our symbol, our element from the periodic table off of the information given as well. So mass number, 65 minus 34, which is our neutrons given, will give us our protons, which is 31. Again, we do the opposite of what the charge is. So 31 minus 3 is 28. That gives us our electrons. So now all we're doing is looking for 31 on the periodic table, which is gallium, Ga. And because we're given the mass number, gallium, it's 65 in the top left corner. The bottom left corner is 31 for the number of protons, or our atomic number. The last part gives us our protons, neutrons, electrons, and mass number. So our protons is 34. We will go to our periodic table. 34 is selenium, Se. And it tells us that our electrons is 36. So since we would add 2 to get that, it's actually a -2 charge. So selenium has 79 in the top left corner, 34 in the bottom left corner, and in the top right corner is the -2 charge. And for our next table, we have two isotopes, lithium-6 and lithium-7, with the mass numbers in abundance given. So let me find my notes over here. The atomic mass, we have to do this lovely multiplication. So for Li6, what we do is we put it in a parentheses and we take the percentage number as a decimal. So that would be 0.0759 times the mass number, which is 6.0151 AMU. You have to write what we're actually measuring. Otherwise, we don't know. Doesn't make any sense. And then we add that to the other percentage in decimal, which is 0.9241 times 7.0160 AMU in parentheses. So that should be what the first step looks like. The percentage in decimal times the mass plus the percentage in decimal times the mass for each isotope. And then that becomes 0.457 AMU plus 6.483 AMU. So that's the next step. It shows there. And of course, we have to remember our significant figures in this. So the last one is step, just gives us the total, which is 6.94 AMU for isotope 6 and 7 of lithium. All right. And the next step sorry if you can hear my kids. It's hard to do this on a Sunday when everyone's home. So the next step is I have to do ionic compounds, and an ionic compound is the name of the cation plus the name of the anion ending in IDE. So the name and the formula of an ionic compound, I gave you 3 examples right there. And that is sodium chloride, NaCl, aluminum oxide, Al2O3, sodium sulfide, Na2S. The next step is binary molecular covalent compounds. You have the prefix, which is the name of the first element, plus the prefix, the name of the second element, ending in ide, IDE. So again, we need examples and name and formula. So here is what that looks like. I wrote it down. You have my name and my formulas. I did way more than what was needed because I wanted that for my own learning. Just going to read them out real quick. Carbon monoxide, CO. Sulfur dioxide, SO2. Carbon dioxide, CO2. Dinitrogen tetroxide, N2O4. Tetraphosphorus decaoxide, P4O10. Dinitrogen pentoxide, N2O5. And the next one is binary acids. So it is hydro plus the name of the nonmetal ending in IC, and then you have the acid. So I have several examples again because I like to have it for myself. And there's all the names plus the formulas. You'll see that I have AQ after every formula because in the book that's what it said you're supposed to do. So I followed directions. Hydrochloric acid, HCl, aqueous. Hydrofluoric acid, HF, aqueous. Hydrosulfuric acid, H2S, aqueous. Hydrobromic acid, HBr, aqueous. And hydroiodic acid, HI, aqueous. And on the very last part here, we have oxyacids. If anion's name ends in 8, ATE, you're going to turn it to the name of the oxyanion ending in IC plus acid. So the examples I have for that are up top here. And I have the name, and then I have the formula behind it. And again, I have more because I needed the examples for myself. Acetate was acetic acid, HC2, H3O2. Perchlorate is perchloric acid. Sulfate is sulfuric acid. Nitrate is nitric acid. Carbonate is carboric acid. Phosphate is phosphoric acid. And the very last one is the name of it ends in ite. So we change it to name of oxyanion ending in OUS plus acid. So that becomes these very last ones here. And that is nitrite becomes nitrous acid. Sulfite becomes sulfurous acid. That is Chapter 2, Teach the Doc.